Hi guys, for today's lesson we're going to be dealing with logarithms. So what do I mean by a logarithm? So a logarithm is a function which is used to solve for unknown powers. So let's give you a situation before I kind of explain what that means. So for example, solve for x. The equation is this: x to the 10 to the power of x, an unknown power, that is equal to 100. So we got to think to ourselves, what would this x be for this equation to be true? And we can kind of see by inspection that if we have a base of 10, if we have a power of 2, that will equal 100. So we can see that our x is equal to 2 because 10 squared equals 100. So this is easy to do just by inspection. But if I give you a trickier sort of equation where x is a power, we need to be able to fall back on some sort of systematic way to figure out what our x is, or to get x by itself. So that's what I'm going to teach you today. So let's do this systematically instead. So what we do, we need to figure out how do we get this x by itself. Well, the idea is we somehow need to make this 10 vanish. The opposite of a base of 10 is actually what I'm going to write it down as log with a little 10 in the bottom right hand corner, and we call that log base 10 because we can see it says log and then this 10 is saying that the base is 10. So log base 10, and I'm going to do that to that side, and what I do to one side I have to do to the other, and the idea is that log base 10 is the opposite of base 10. So it's really important to understand that that this 10 and this are opposites and they cancel each other out. So as we see here, they're going to cancel each other out. And when we apply this log base 10 to the 100 over here, this is what it looks like. The 100 actually goes in some brackets next to the log base 10. You don't need to put the brackets there, but it's helpful just to show that what the log base 10 is applying to. It's applying to the 100. The x is now by itself. Brilliant. If we shove this into a calculator, and the way that we do it is by putting that into our calculator, there's a log button. We put the 100 into the calculator. You don't have to worry about the 10 because the calculator assumes that when you press this log button that the base is a 10, it'll come out with 2. So this pretty much is a way of getting your calculator to tell us that x is equal to 2 as we saw before. Okay, so let's go to a general rule for this. So when you are given this sort of equation, when you've got an x as your power and you're trying to solve for this x, and you've got some sort of base a and it's equal to some sort of number b, that is equivalent. We can change this equation to look like this. So they're pretty much the same sort of thing. So what we saw before was that this equation right here is equivalent to this. We need to be able to quickly go from that to that. So so the general rule of thumb is that your a is your base, which is your a here, is going to be like the small letter that's next to your log. Next is that your power is going to end up being the subject, like the value by itself, and the b, which was originally the subject, that is going to be coming after your log. That's like the part which is like in the brackets, but you don't need to show those brackets. So it's really important to be able to go from this to this really quickly. And if you're wanting to use this idea of log being the opposite of the base, then so be it. That's probably the best way to do it because you can see exactly how it cancels. Okay, note your calculator can't calculate these logarithms that don't have a base of 10. So it only worked because our base was 10. If it was any other number, your calculator wouldn't be able to handle it. So I gave you one that worked, but a lot of them won't work. So we're going to deal with those sorts of situations today. So determine whether the following logarithmic statements are true or false. So here, the first one they've given you is this one here. We've got to think, is this true or false? So the way to do this one is to apply this rule, that is equivalent to that. So what we do is we think to ourselves, well, they've given us this statement. So it's like they've given us this part here. We need to be able to work backwards to make sure this is true or false. So first step, we think to ourselves, well, 5 is our base for our log function, so therefore we can change it so 5 is actually the normal base. The 25 is usually the number that goes by itself, and the 2, the part that, like the subject here, actually goes back to being your power. So this line that we give you is equivalent to this, and we got to check, is 5 squared equal to 25? That is true, so that suggests that this, which is equivalent, just the same thing but in a different form, that should also be true. So it's all about checking whether this part was true, because that one's a lot easier to see compared to that one. Okay, let's move on. Let's try another one. So this one here, log base 2 of 6 is equal to 3. So we get that the 2 is our base, so we make that the base. The 6 is the number that's going to be by itself, and the 3 is going to be your power. So we get that 2 to the power of 3 is equal to 6. That's definitely not the case, because 2 to the power of 3 is actually equal to 8. So therefore it's going to be false, meaning that our original equation here, which is equivalent, is also false. Question 2, determine the value of the following. So we want to figure out what log base 4 of 16 is equal to. So the way to do this, because our calculator can't handle this, because the base is a 4, not a 10, we need to let x equal this. So we let this equal something unknown. We don't know what this is equal to, so let's say that it's x. Hence, let's switch this equation up into a better form. So therefore, our base is 4, so let our base be a 4. The part by itself, x, becomes our power, and the 16 becomes our number by itself. We get an equivalent equation of 4 to the power of x equals 16. Therefore, we can see that our power of x must be a 2, because that will give us a 16. So therefore, our x is equal to 2. And we were trying to figure out what this is. And this is equal to x, and we can see that x is equal to 2. So all we need to pretty much do is say that that is equal to 2, because that's what we can see, that x is right there. So therefore, our log base 4 of 16 is equal to that 2. Question B, let's try another one. So again, we don't know what this is, so let it equal x. So it's all about figuring out what x is, because that's what we're trying to find, this thing here. These two things are exactly the same value. So if we find x, we find this one. Okay, so switching it around, our base is a 2, our x is the power, and our 64 is what it's equal to. These two things are equivalent. We know that 2 to the power of 6 is 64, so therefore your x must be a 6. And because x is what we're trying to find, therefore our original expression is equal to that 6. Hope this helps with the questions. Good luck.